All right, folks, we are in Chapter 8. This is Section 8-4. This is recording number 2, and I am going to do example 8-20. Okay, so again, this is a metaphor. It's not a problem that you would particularly be interested in, but the attorney claims that more than 25% of all lawyers advertise. So that's the claim. That's the null hypothesis, that P equals 0.25. That's the proportion. So how do you test this? You go out there and you get a random sample of 200 lawyers, and out of the 200, 63 used some form of advertising. So my P hat, my successes over N, is 63 over 200. We're going to consider this problem at an alpha of 0.05, and we ask the question, is there enough evidence to support the claim? Here's the claim, that P is greater than 0.25, is greater than the 25%. Okay, so it's just a matter of cranking it out, really. Up on top, you have how surprised are you? The P hat is the results of your experiment. P is the hypothesized value for the proportion. So P hat, take away P, that's how surprised are you. And then on the bottom, that is the yardstick that we're going to use. Okay, so we're just using the same formula that we've been using all along. And what do we get? 2.12. Okay, so now what you'll notice here is we never computed the critical values because the problem said to use the p-value method. So what we want to do is we want to say, okay, this is my test value. I'm right here. I'm at, give me 1 second. If I use this as kind of a cartoon and I say the hypothesized value, what I claim as part of my null hypothesis, if I claim that it's the proportion of the population is 0.25, it's going to look like this. There's going to be some sort of a distribution like this, a normal distribution. This is a normal distribution, and the mean is 0.25. That's what my null hypothesis says, that is 0.25. Well, I did an experiment, and I came up with a value of 0.315. I looked out there and I grabbed 200 lawyers, and out of the 263 are advertising, so it's 0.315. Now again, this is a metaphor. This could be how many people tested positive for a virus. Okay, we grabbed 200 people, 63 of them tested positive, so it's 0.315. So is 0.315 significantly different from 0.25? Is that a lot? I don't know, because I haven't done the experiment yet, okay, or I haven't done the testing yet. I haven't done the Z testing yet. So I go ahead and do the Z testing, and I come up with 2.12. So that's the Z value for this experiment. That's what I get for my test value. So 2.12. Now, in this example, we're using the p-values. We want to find out what the p-value is. That's why I drew it like this, as opposed to drawing it like we normally do, where we have the critical values and we're doing it on the standard normal distribution. Here we're doing it on the raw data, the population distribution here. Okay. So my goal now is I need to find out what is the p-value. What's the p-value? Okay, so he explains that here, but I don't think it's going to do any good for me to just read that to you. You can read that yourself, but read it carefully, pencil and paper in hand, and now let me see if I can try to make a little more sense out of it. Okay, and this is the hard part, bouncing between the screens here on the computer for this video. So let me bounce over to the table. We need table E. And let's remember that Z is 2.12. The corresponding Z value for this particular P value, where does it place me? It places me at Z of 2.12. So let me go to that. So if I'm at 2.12, so here's 2.1, here's 2.12. That's 0.9830. 0.9830. So what that's telling me is that 0.9830 is the area to the left of that particular z value, right? Now, you've done this a million times, I hope, so that should make sense to you. Okay, so if my test value comes back at 2.12, that's where I'm at. So what that is also telling me is going past that point, what is the area under the curve here? Well, if the area under the curve to the left is 0.9830, the area to the right is 1 subtract 0.9830. In other words, 0.0170. So 0.0170 is the area to the right of this corresponding z value. So let me get rid of this. Okay, and that is exactly what he has, 0.0170. That's the area to the right. So what that's telling me is the p value is 0.0170. That's the probability that I would obtain this number right here, the 0.315, probability that I would obtain that number or more by random chance. It's a 0.0170 probability. So in percentages, that's 1.7% probability that I would get this number and to the right. Okay. All right. So give me 1 second. Okay. So now up above here, they told me that alpha is 0.05. I haven't even used that yet, okay, but I'm going to use that now. What I'm going to say is, well, the error budget, the alpha is 5%. This is so unlikely, it would only happen 1.7% of the time. That is obviously less than the alpha value. It's less than my error budget. That it's so unlikely that this would happen. It would only happen 1.7% of the time. I am therefore going to reject the null hypothesis. And that's what he says right here. 0.0170 is less than 0.05. In other words, the p-value is less than the alpha. Here's the cartoon. Therefore, I reject the null hypothesis. So, in conclusion, there is enough evidence to support the attorney's claim that more than 25% of the lawyers use some form of advertising. Now, you should always do, when I was in the engineering business, we called it a sanity check, because you could make a mistake. You could have a plus or minus sign wrong, or it's so easy to make mistakes, as you know. So look back. Does it make sense? Does it make sense that we would reject the null hypothesis? The null hypothesis being that P is equal to 25%. When he grabs 200 guys at random, he does the questioning and he does the survey, and he comes up with a 31%. 31%, that's quite a bit different from 25%. So it makes sense. I can believe it. I'm not going to quibble about it, okay? So it's always good to do that little sanity check on these things, okay? Okay, well, that's the end of section 8-4. Section 8.1 was the long one, because that, or 8.2, I mean, was the long one, because that kind of taught us everything we needed to know, and now we're just applying it to these different tests. So that's the end of section 8-4. This is video number 2.